Hi, chemistry. We're going to talk about alkenes and alkynes today. Basically, we've got a few more structures to get through, a couple of types of reactions, and then we're going to be done the course. All right, so let's have a look here. Hydrocarbons with double or triple bonds are unsaturated. That's because if those double or triple bonds disappear, there's room for more hydrogen. We'll get into that later. Okay. If there's a double bond between carbon atoms, we have an alkene. And if there's a triple bond, we have an alkyne. They're named the same as alkanes, except their suffix, the way they end, is with ene or yne, so ene or eine, right? So we have alkanes, alkenes, alkynes. Here are the two simplest versions. So if you have double bonded two carbon atoms, right, that would be ethane if it was single bonded, but since there's a double bond, it's ethene. Okay. A triple bond means it's going to end in yne, 3 carbons, means this is propyne. Okay? If it was a double bond, it would be propene. If it was a single bond, it would be propane. All right, let's move on here. Those were simple versions. If there's more than one possible location for the multiple bond, you need to show where it is between the prefix and the suffix. I'll show you what that looks like. Okay, so we got two examples here of butene. This first one, the double bond's in the middle. So if you number these carbon atoms, 1, 2, 3, 4, it doesn't matter what side you go from, the double bond starts at the second carbon atom. Okay, so you write that as but2ene. Here it's on the first carbon atom. That one's but1ene. Okay, so there's two types of butene. The same thing would happen if it was a triple bond. If it was a triple bond, this would be but2ine. This would be but1ine. Okay, branches are dealt with in the same way, but there's actually a nice rule that always holds true. You start numbering atoms from the side closest to the multiple bond. Okay, so I've got this structure here. Looks like I have 2 methyls. We know how to deal with that. My parent chain has 1, 2, 3, 4, 5, 6 carbons. There's a double bond. So this is hexene. You number the carbon atoms starting from the side closest to the multiple bond. So even though methyl, if we start from here, would be at 2, we start from this side because it's closer to the multiple bond. So it'll be 1, 2, 3, 4, 5, 6. Okay. You indicate the location from where the multiple bond starts. So we mentioned this is hexene. Since it starts at number 2, this is going to be hex2ene. Now we deal with the branches. I got a methyl at 4 and a methyl at 5. This is going to be 4,5-dimethyl hex2ene. All right. I got some more for us. I'm going to throw some line structures at you. So this one looks pretty cool. I think they always look cool in this format. So we have to indicate the parent chain. It's got 1, 2, 3, 4, 5 carbons. So that's pentyne. These 3 lines mean there's a triple bond here. Okay? The triple bond, I like to put little nodes for where the carbon atoms are. The triple bond starts at carbon 2. All right, so that's going to make this prop2ine, and it looks like we have a methyl at 4. So this is going to be 4-methyl prop2ine. Now, you can also get cyclic alkenes or cyclic alkynes. They are rare. You won't see them too often, but here's one. Okay, they have a nice rule. You always start numbering, excuse me, everybody, where the multiple bond starts. Okay, you can go clockwise or anti-clockwise. This one's not going to matter. So you always start at the multiple bond. I'll make this 1, and then we'll go this way. We'll get the same numbers if we go the other way. The fact that the multiple bond is always at 1 for cyclic versions means you don't have to say where it is because it's always at 1. So this is cyclohexene, and it looks like it has methyls at 3 and 6. So this would be 3,6-dimethyl-hexene. Again, you never have to put the number for a cyclic version. Oops, I forgot that it was cyclic. That's not correct. This is 3,6-dimethyl-cyclohexene. Cool. Check out this cool looking one. All right, so we can see it's an alkene, a double bond. The parent chain, you can go either way when you get to this kind of intersection here. I'll go up. So I got 1, 2, 3, 4, 5 carbons in the parent chain. I'll number them. Okay, it looks like I've got a double bond at carbon 2. So this is going to be prop2ene. All right, looks like I have a methyl there and an ethyl at 3. So the first thing I'm going to write is the parent chain. It's prop2ene, not prop, my goodness. Sorry everybody, that's pent2ene. All right, I got a methyl and an ethyl. Which one comes first? Remember, it's alphabetical. So the ethyl actually comes before the methyl. So you're going to write 3-ethyl, 2-methyl. Pent2ene. That's what that is.